Assalamu alaikum, dear students. Welcome to all of you in Network Professionals, the Cisco Networking Academy, and I am your instructor Ahmed Malik. Remote access technologies. Based on the needs of users just described, a wide range of technologies can be used to provide remote access. Some of the traditional technologies include frame relay, leased lines, ISDN, and dial-up links. Newer technologies include DSL, cable modems, and wireless technologies such as 802.11x. VPNs have also become a significant technology in the past few years. They can provide an alternative to expensive leased lines in a central office or branch office scenario. Also, they can provide security to their users who use them over DSL and cable modem networks to connect to the central office. IPsec VPNs are a good example of later scenario. Frame relay, one of the most important remote access technology. Over the past few years, frame relay has been one of the most popular remote access technologies. It offers a high-speed connection between a central office and a branch office. One of the frame relay's benefits is built-in congestion control to combat blustery traffic. As bandwidth needs have increased over the years, this technology has proven very popular. All frame relay circuits can be ordered from providers in a variety of bandwidths, starting at 56 kbps. These are usually fractions of a T1 link. This allows for flexibility when planning. Some of the services that can be used over frame relay networks are data, voice over IP, voice over frame relay, and IP multicast. Frame relay operates at layer 2 by encapsulating layer 3 traffic such as IP within a frame relay frame. To improve performance, frame relay relies on higher layer protocols such as TCP to overcome corrupt or dropped frames that occurs during transmission. This is different from protocols such as X.25 that have built-in error checking or correction. Often frame relay is described as a successor to X.25. Frame relay employs its own addressing scheme at layer 2 to specify a frame's destination. This feature is called DLCI, stands for Data Link Connection Identifier. This field in the frame relay header tells the frame relay switch where to route the frame. The DLC can thought of as the media access control or MAC address in the case of frame relay network. Another advantage of frame relay is its capability to establish one-to-many connections. This is often called point-to-multipoint. This capability can potentially allow the redirection of traffic around an outage, provided that a partially meshed network exists. One of frame relay's drawbacks is the high cost of provisioning links. The high cost can possibly be justified in a branch office scenario, but it might be unsuitable for single remote users. Another most important remote access technology is serial links. This type of network has also been historically popular in connecting branch offices. These lines can be ordered from a fractional T1 such as 56 kbps up to DS3s. Possible fractional T1 link speeds include 56 kbps, 128 kbps or 256 kbps and so on. A full DS3 has a speed of 45 Mbps. These networks do not provide any of the congestion control or error detection capabilities that frame relays provide. The onus is completely on the higher layer protocol to provide such services. As with frame relay, cost is also an issue with these links. Another most important remote access technology is ISDN, stands for Integrated Services Digital Network, ISDN. ISDN remains one of the most flexible and widely offered services today. Providers all over the world offer ISDN services to the users. ISDN basically comes in two varieties: basic rate interface BRI and primary rate interface PRI. Basic rate interface BRI, which consists of two 64 kbps bearer channels and one 16 kbps data channel. This is often represented as 2B plus D. For the 2B or bearer channels and one data channel, this has traditionally been the choice of many remote users who connect to the offices from their residences or home. It remains popular especially with users who do not have DSL or cable services available at their residences. Primary rate interface PRI, which in the US consists of 23 64 kbps bearer channels and one 64 kbps data channel. This is often represented at 23B plus T. But in Europe, PRI consists of 30 64 kbps bearer channels and one 64 kbps data channel. PRI services are often used when greater bandwidth is needed, such as when a connection is needed between a central office and a branch office. Lately, ISDN has been replaced in many homes and small office home office environment by technologies such as DSL and cable modems, which offer much higher transfer rate. These services are also cheaper because they offer flat rate pricing. The combination of these factors has made these technologies more attractive than ISDN. One another most important remote access technology is analog dial-up service. Analog dial-up service is the most ubiquitous remote access available. All you need in a phone line and a modem. Speeds, which started out around 300 bps, have steadily increased over the years to 56 kbps. Users using analog dial-up usually connect to an access server using a modem. The provider that operates the access server gives the user a phone number. The user connects to the access server using that phone number. If in the same calling area, the user can connect to the provider using a local phone number. If the user is not in the same calling area, many providers have toll-free numbers. This allows users to connect without incurring long distance charges or using calling cards. Some providers also offer softwares that has a list of phone numbers organized by this country. Users can use this software to select the appropriate number for their location. They can then connect from all around the world. Users can also connect to the internet via dial-up and then users use VPNs to connect to their corporate networks. Many operating systems now offer native VPN selections such as Microsoft point-to-point tunneling protocol (PPTP). The most obvious drawback of dial-up services is the speed or lack thereof, with applications becoming more and more bandwidth intensive and other broadband options becoming more cost effective. Users are turning away from dial-up. Today is one of the most widely used remote access technology is DSL, stands for Digital Subscriber Line. In the past few years, DSL has emerged as one of the technologies that can provide broadband services to homes. This technology can support both high-speed data and voice at the same time. It also can support data transfer rates of up to several megabytes. Certain flavors of DSL can deliver speeds of up to 52 Mbps. These transfer rates are made possible by using unused frequencies on copper telephone lines. The available bandwidth is divided into frequencies ranges. One frequency range is used for voices, another is used for upstream data transmission, and another is used for downstream data transmission. For example, voice uses the frequency range of 0 to 3.4 kHz and asymmetric DSL uses the frequency ranges of 25 to 138 kHz in the upstream direction and 172 to 1104 kHz in the downstream direction. Splitters are sometimes used to separate these frequencies. Another feature of DSL is that it is always on. Unlike ISDN and analog, no dial-in is required. This is an attractive feature, especially for users who are accustomed to cumbersome call setups and busy signal associated with analog dial-up services. DSL offering can be broadly divided into two categories: asymmetric DSL and symmetric DSL. Asymmetric DSL is in this category. The upload and download speeds differs. Here are some of the different asymmetric DSL technologies like asymmetric DSL ADSL, rate adaptive DSL RADSL, very high bitrate DSL VDSL, and consumer DSL, stands for CDSL. Symmetric DSL. In this category, the upload and download speeds are the same. Here are some of the different symmetric DSL technologies like symmetric DSL SDSL, integrated service digital network DSL IDSL, and high speed bitrate DSL HDSL. DSL has a wide range of offerings that users can choose from. Also, DSL's always on feature and its support of a wide range of applications make it an attractive technology for many remote users. DSL does have its drawbacks. Its distance limitation is a significant issue. DSL services cannot be offered beyond certain distance from the central office. Also, DSL is not as ubiquitous as other services like dial-up and ISDN. Today's most important and widely used remote access service is a cable net or cable services. The demand for high-speed internet access in the past few years has been the rise of cable modem service as a broadband alternative. The technology takes advantage of wide reach of cable infrastructure used to deliver television services. Data is transmitted over the network as radio frequency signals. The cable modem converts these signals into digital signals. In addition to television and data signals, analog voice signals can also be transmitted over the network. These systems can also perform full duplex communications. The fiber coming from the homes of subscribers is usually aggregated in remote units, and fiber is used to connect these units to head-end routers. This kind of hybrid network is also called a hybrid fiber coaxial HFC network. Different frequency ranges are used to transmit in upstream and downstream directions. The cable modems use channels in the range of 5 to 46 MHz range to transmit data in the upstream direction, and similarly a TV channel in the range of 50 to 750 MHz range is used for downstream traffic. Cable can support a significant amount of bandwidth, enough bandwidth to allow subscribers to watch television and be on the internet at the same time. The cable modem uses 10/100 Ethernet or USB to connect to the user's PC. In addition to bandwidth, cable is also attractive because of the wide range of applications it can support. Data, voice, and video can all be supported by this medium. Conversely, because cable is a shared medium, performance can be degraded if too many users are on the same segment. This is the most significant drawback of cable. The shared nature of the medium also raises security concerns because traffic can potentially be captured using a packet sniffer tool. Also, the frequency range used for upstream communications is vulnerable to interfaces caused by household applications.
That's enough for today and stay connected for all upcoming videos. Thank you very much.